Okay, we're moving on to section 7.3. The rest of the chapter is really all about quadrilaterals, and so this is the introductory section for quadrilaterals. A quadrilateral is a four-sided polygon. I think most of you knew that. There are a bunch of different types of quadrilaterals that we're going to introduce here, most of which you have seen, I'm sure, at some point or another in whether it's in elementary school or in middle school. The first one here is a parallelogram, and a parallelogram has two pairs of opposite sides parallel, and that's the definition of a parallelogram. Now, the next three are kind of interesting because they're kind of defined in terms of them being parallelograms. So for example, a rectangle is a parallelogram. Okay, so it's a parallelogram that has at least one angle that's a right angle. And we know that if one of the angles is a right angle, and if it's a parallelogram, we know that these two sides are parallel to each other. We know that these two have to be supplementary to each other. So that means that this one also has to be a right angle. And likewise, if these are parallel to each other, then these two also have to be right angles because, for example, the two bottom angles here are going to be supplementary to each other. A rhombus is defined as a parallelogram where at least two consecutive sides are congruent. And so we know that it's a parallelogram, so it's like this. And if these two sides are congruent to each other, like this one and this one, we can actually do something like this, where we draw in a diagonal, and we can prove that these two triangles are congruent to each other because we know that these are alternate interior angles, and these are alternate interior angles right there. And you got a reflexive side down the middle, which means that these two triangles are congruent, which means that the top and bottom are congruent to each other, and the two sides are congruent to each other, which means that all four sides are actually congruent to each other in a rhombus. So that's kind of an interesting way that rectangles and rhombuses are defined. A square is defined as a parallelogram that is both a rhombus and a rectangle. And, I think most of you know what a square is, at least conceptually, most of you have some idea of what a square is. A kite is another quadrilateral, and a kite has two disjoint pairs of consecutive sides congruent. So what it's meaning is that these consecutive sides are congruent to each other, and these consecutive sides are congruent to each other, which makes it a kite. A trapezoid is the next one, and a trapezoid is a quadrilateral that has one pair of opposite sides parallel to each other. So the weird thing about that is you could end up with a trapezoid that looks like something like this. That is actually a trapezoid, even though it doesn't look like what we normally would see in a trapezoid. These two parallel sides are called bases. These two non-parallel sides are called legs. An isosceles trapezoid is the last one, and that's basically a trapezoid where your legs are congruent to each other. So two pairs of opposite sides, or one pair of opposite sides parallel, and the legs are congruent to each other. And normally what we would do in class is we would take this chart here and we would go ahead and try to fill this chart out. Basically put a little check mark next to things that are true. If you want right now, you can pause the video and go ahead and try filling this chart out. Okay, I gave you a moment to pause the video, and now we're back. And so I'm going to go ahead and fill this out. The way you can do this is you can either memorize the different properties of the various quadrilaterals, Or you can kind of figure out some of these properties. So here's what I mean. In a kite, so let's scroll back up and take a look at a kite. And here's where our kite was. In a kite, you can see that these two pairs of consecutive sides are congruent and these two pairs of consecutive sides are congruent. So if I draw in the diagonals like this, hopefully you can see that this diagonal, the one that's going up and down vertically, has to be the perpendicular bisector of this diagonal right here, and that would be because of the equidistance theorem. And so because of that, we know that the diagonals, if I look at this thing, the diagonals are perpendicular to each other. And as it turns out, I think that's the only property that is true for a kite. And there's a lot of things you can figure out with the parallelogram using the proof that we kind of did, the little scratch proof that we did up above with the parallelogram. We know that by definition, this is a parallel symbol, by the way, and this is also a parallel symbol. By definition, we know that two pairs of opposite sides are parallel. We also know that two pairs of opposite sides are congruent. We did a proof on that, basically showing that the two, if I draw in a diagonal, the two triangles are congruent to each other. And as it turns out, this is going to be true also. The opposite angles are going to be congruent, and consecutive angles are going to be supplementary, and the diagonals will bisect each other. And those are all things we can go ahead and prove using two-column proof. Now, the nice thing about that is we know that these three are all parallelograms. That's the definition. By definition, all of them are parallelograms. So we can go ahead, and because we know the properties of a parallelogram, we can go like this. This is true. 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 And now we just need to add a few more properties. As it turns out, for a rectangle, you can add these two. The opposite angles are congruent because they're all right angles. And we know that they're all right angles, so that's true. And I believe the diagonals are congruent to each other, yes. And you can do a quick sketch and kind of show that that's true. If I were to quickly draw a rectangle, hopefully you can see that these diagonals would have to be congruent to each other. In a rhombus, where all four sides are congruent, I know that all sides are congruent, so that's this property right there. I also know that the diagonals are perpendicular because of the equidistance theorem, and I know that the diagonals actually bisect the angles. And now, because a square, keep in mind, a square was defined as a rectangle and a rhombus, and a parallelogram. So all the properties that are true for a rectangle and a rhombus have to be true for a square. So that means that this one's true, 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 and this one's true. It's a lot of properties that are true for a square. Okay, and then the last thing here, let's talk about trapezoids. Trapezoids, one pair of opposite sides are parallel, so that's this one right there, and I think that's it for a trapezoid. We know that that has to be true for an isosceles trapezoid also. One pair of opposite sides are congruent because the legs are congruent to each other. And the last thing is that the diagonals for an isosceles trapezoid are congruent to each other. So those are all the properties that you need to know for each of the various types of quadrilaterals. So let's flip over to the next page. So here we are on the next page, and we're talking about all the various properties of a quadrilateral. If you look at this diagram here, what this basically is it's a little bit of a flow chart, and basically the idea is towards the top is the most general type, and then as you move downward, it gets more and more specific. So for example, you have a parallelogram here, and then there's a rhombus and a rectangle are specific types of parallelograms, and you know that together a parallelogram that's a rhombus and a rectangle is a square. And then you have a trapezoid, and a more specific type of trapezoid is an isosceles trapezoid. The nice thing is you can see actual representations of the various figures here. So for example, this is the shape of a kite, and like this is the shape of a trapezoid, etc. Okay, and that's a literal representation there. And then inside each of the boxes, or inside each of the shapes, is a list of the various properties. So this is just another way to represent the different properties of quadrilaterals, and another way for you to try to remember the various properties, because you'll need to know the definitions as well as the properties of the different types of quadrilaterals. One thing you might want to use is there's a couple of tools out there. I know that most of you are familiar with Quizlets. Not sure if I'm spelling that correctly, but I know that there's various Quizlets out there helping you to remember the properties of quadrilaterals. And I've also seen a lot of people kind of do flashcards. So on one side of a flashcard, they'll put the definitions, and they'll put like a drawing on that side, and then on the other side, they'll put all the properties. And just kind of walk around with those flashcards and use those to help you memorize the various properties. So on this next page here, it's another way to help you try to remember some of the properties and definitions of quadrilaterals. So for example, this first one here, what you're supposed to do is identify whether these statements are true or false, and then if it's false, then go ahead and do something to make it so that it's true. So for the very first one here, for example, problem number 1, a parallelogram is a rectangle, and that is sometimes true, but it's not always true, because or it's not the only thing that's true, because a parallelogram could be a square. A parallelogram could be a rhombus. So in this case, I could change the P parallelogram to a square, and that would be a way to fix that statement. So to make it so that it's always true. A square is always a rectangle, and that would be the way to make that true. So that one is what you would do. Again, if you could turn off the video right now and try this worksheet, it's a way for you to practice the properties of a quadrilateral. And now we're back. Let me just quickly go over the answers here. I'm only going to go over the ones that are false and need to be fixed. The other ones are going to be true. So if I look at this sheet here, it looks like the next one that's false is going to be number 5. So a rhombus is equiangular, and it's not necessarily equiangular, but we know that when it's a square or when it's a rectangle, it would be equiangular, because then all the angles would be right angles. Number 6, a rectangle is equilateral. It is equilateral when it's a square, but not always. So the way to change that would be to make this equiangular. So we know a rectangle, of course, is always equiangular. Moving on down to number 9, consecutive angles of a rhombus are congruent, and that would not necessarily be true, but again, for a square and a rectangle, that would be true, because they would be right angles. Number 11, the diagonals of a rhombus are congruent to each other, and that would be true only in the case when it's a square or when it's a rectangle. And then moving on down the page, number 12 here, the diagonals of a square may not be congruent, and that's not going to be true, because the diagonals of a square are always going to be congruent, but it is true for the case of a parallelogram as well as for a rhombus. Number 13, in any parallelogram, the diagonals are congruent. not always true. It's only true always when it's a square or when it's a rectangle. And then the last one that's false is number 14. If the diagonals of the parallelogram are perpendicular bisectors of each other, then the parallelogram is a rectangle. That's not true. It would be a rhombus or a square. So on this next page here, it's a Venn diagram, and you're supposed to take all the various types of quadrilaterals that we've talked about and put this in the various blanks here. So for example, the biggest box here, I guess, is quadrilaterals. So all the things that we've talked about are quadrilaterals. A subset of quadrilaterals would be trapezoids, and a subset of trapezoids would be isosceles trapezoids. And then another subset of quadrilaterals would be parallelograms. And we know that a rectangle and a rhombus are both parallelograms, but when they are together, both a rectangle and a rhombus, then they would be in this crossover region here, and that would be a square. And then the one last thing here is that a kite is sometimes a parallelogram and sometimes it's not. So that's why it's out here. But when it's a square, because a square is a kite and a rhombus is a kite, then it would be inside the parallelogram box, and so that's where a kite would be. That's when a kite would be a parallelogram. This is where having the Venn diagram is useful. So when we're doing always, sometimes, nevers, or true, false, with problems like this, it does get a little bit confusing. So for example, when it says a parallelogram, for number 2 here, a parallelogram is a rectangle, we know that a parallelogram is sometimes a rectangle, because it could also sometimes be a rhombus, sometimes be a square, etc. And then you can go through and fill out this entire thing here. So if you would, again, pause the video and try this entire sheet, and then I will go over quickly the answers to this worksheet. And we're back. Just very quickly, let's just go down the column here. So number 1, it would just be always, sometimes, never, always, sometimes, never. 13 be always, never. 17 is sometimes. And then all the way down here, 19 is going to be sometimes, never, sometimes, always, never, sometimes. Okay, how did you do on that column? And then I'm going to go ahead and fill out the rest of this column. So number 4 is sometimes, always, sometimes. Always, always, sometimes. And then sometimes, always, sometimes. Don't see any nevers yet. Too soon. Number 22 is never. Never, never. And then always and sometimes. So if you did well with that, you're in pretty good shape for the always, sometimes, nevers and the true, false that you'll probably see on the homework as well as on tests and quizzes. So good job. And that's it. So go ahead and try some of the homework now. All right, take care.